A 0.25 kilogram baseball is thrown upward with a speed of 30 meters per second. Neglecting friction, approximately what is the maximum height reached by the baseball? So we know the initial velocity. Yes, I'm saying velocity since we know the speed and the direction of that speed. We know it to be positive 30 meters per second, where positive is upwards. We also know that the acceleration due to gravity on Earth is downwards, 9.8 meters per second squared. We know that the final velocity of the ball at its maximum height is going to be 0 meters per second, since when a ball reaches its maximum height after being thrown upwards, it will have a 0 meter per second velocity before that velocity begins to change downwards as the ball falls back to Earth's surface. And we want to know the displacement of the ball at this maximum height. So we can use this equation. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Note that I'm using the vector form of this equation, and I think that that's, in general, a good practice, as that way you can determine directions. So we know final velocity is 0, so this term will be 0. We want to isolate for displacement, so we'll subtract v0 squared from both sides, leaving us with negative v0 squared equals 2 times acceleration times displacement. We'll divide both sides by 2 times acceleration to get displacement on its own. That'll leave us with displacement equals negative v0 squared, which will be negative 30 meters per second squared, divided by 2 times acceleration, 2 times negative 9.8 meters per second squared. Now we'll evaluate the numerator and denominator separately here. So we'll have negative 30 squared in the numerator. 30 squared is 900, so we'll have negative 900 meters squared per second squared. And that'll be over 2 times negative 9.8, which is negative 19.6. The units are meters per second squared. Note that in the numerator and denominator, we should technically only have 2 significant figures. I'm keeping more in the denominator for now so that we get an exact result for this division. The second units will cancel, one of the meter units in the numerator will cancel, and we'll be left with final units of meters. Negative 900 divided by negative 19.6, rounded to 2 significant figures, leaves us with 46 meters as the maximum height reached by the baseball. And that is positive, meaning that it's above Earth's surface. So this is the final answer for this problem.